All right, today we're going to learn how to reduce or simplify rational expressions. This is 10-1 in your book. All right, so when I have the fraction 20 divided by 24, I can simplify this by simply breaking each number down into its prime factors. So I can break 20 into, and what I can do is just divide out common factors. Common factor of 2, another common factor of 2. And then what I'm left with is 5 over 6. Now this takes too long to break down our numbers that much. But we're basically doing the same thing when we factor. So when we have single numbers, we don't do it that way. But when we have variables, we break down the numbers into what makes the fraction, what makes up that fraction. So you can see in the numerator with 5, a to the third, b to the second, I can break it down like this. I have 3 a's that are multiplied together, 2 b's over. Now I can divide out my common factors. So it's really easy to see what's actually left. I have an a squared over 7b. Now, like I said, it takes a long time to expand the numbers. So we can simplify the fraction right there within the fraction. So I can divide a common factor out of 5 and 35, and I'm left with 7 in the denominator. I can divide a common factor out of a to the third and a, and I'm left with a squared in the numerator. Now in the denominator, I'm actually left with, when I don't have anything else to write, I'm left with 1. I just don't write it, okay? So with b squared and b to the third, I can divide 2 b's out of the numerator, and I'm left with a 1 over b. And so what's left in this fraction is a squared over 7b. The second method is how I'd like you as algebra students to be breaking down these fractions. It's quicker, and it's going to get to be way too long if I get something like a to the 30th. All right, so now you try it. Number 1, pause the recording and do number 1. Now check your work. I can divide out a 2, and I'm left with a 3 and a 5. I can divide out an x out of the numerator and denominator, and I'm left with an x, and a y, and I'm left with a y to the third in the numerator. So my final answer should be 3x y cubed over 5. Number 2 is going to be a little bit more different. In this one, we're going to be kind of blending chapter 6 and chapter 10. Now what we need to do is factor. 5x plus 10. I can factor out a 5. And I'm left with an x plus 2. Now, when I get the binomial x plus 2, I can divide out that common binomial factor, which is x plus 2. Now, here's the rule on dividing out binomials. To divide out a binomial, the binomials have to look exactly the same. I just can't take a piece of a binomial. For instance, let's go back for a minute. I cannot cancel my x's this way or my 2's this way. It's not allowed. There's no mathematical justification for something like that. But what I can do is any number over itself, x plus 2 over x plus 2, binomial over binomial, okay, that I can cancel out as a factor of 1. So I can only cancel the binomial factor out if there's one that looks exactly like the binomial. You can't take part of it. So what I'm left with is 5. All right, now let's take a minute and look. This is why we really can't factor out a binomial unless it looks exactly the same. If I get something like 3 plus x over 3, that's the simplified expression. If I get 3x over 3, I can divide out that common factor of 3 over the multiplication sign. And I end up with x. Now, reason being, so when there's a plus sign, I can't divide out the 3's. I have to divide out a common binomial. For instance, if I had 3 plus 4, if x equaled 4, that wouldn't be able to be simplified. But in the other problem, when x equals 4, 12 divided by 3 is divisible by 3, and I would get 4. So you can see here, if I'm dividing out a binomial, it has to be exactly the same, not a piece of a binomial. All right, so rule number 1 is factor. Number 1, we have a difference of squares. So I break it down to x plus 5 times the quantity of x minus 5. The denominator, I can divide out a common factor of 5. And I'm left with an x minus 5. Step 2. Now I simplify and divide out common factors. I can divide out an x minus 5. And what I'm left with is x plus 5 over 5. Now remember, this is where we have to stop. I cannot divide out those 5's because I do not have exactly a binomial factor. Pause the recording and you try number 2. All right, now let's check your work. You should have factored to 3 times the quantity of x squared minus 9, which again breaks down to 3 times the quantity of x plus 3 times x minus 3, all over x plus 3 times the quantity of x minus 7. My x plus 3's cancel out, and we are left with 3 times the quantity of x minus 3 over x minus 7. Now you can stop there. We don't need to multiply the 3 back in. I don't need to bring this 3 back in here. I can just leave it like that. I'm done. I've simplified as much as I can, and I'm done. I stop. All right, now factoring opposites. Let's look at a 7. The opposite of 7 would be a negative 7. The opposite of y would be negative y. The opposite of x plus 3 would be negative times the quantity of x plus 3, or negative x minus 3. The opposite of y minus 8 would be negative times the quantity of y minus 8, or negative 8 plus 8. Negative y plus 8. And notice I'm just turning it around. So if I distribute this, okay, I get negative y. If I distribute it again, I get negative positive 8. Now all I'm doing is moving the positive one here and the negative one here. Just looks a little bit cleaner. All right, if I have 2x minus 3, the opposite, or 3 minus 2x. Notice they are opposites. 6 minus 5 really makes 5x minus 6. Last but not least, t minus 8 becomes 8 minus t. Now, to rewrite each factor as a product of negative 1 and its opposite, so what's the opposite of negative m? Is m. So if I take negative 1 times positive m, I would get the equivalent of negative 1. So I'm rewriting every single one of these as a product of -1 and the opposite. So what's the opposite of D? It's -D. So -D times -1. Okay, pause the recording and see if you can finish this up. All right, now let's check our work. I have -1 times the opposite of x is -x is x, and the opposite of 4 is +4. Now, if this is a binomial, make sure you put that into parentheses, because that -1 is getting multiplied. So number 4 would be -1 times the quantity of 3 minus b. Number 5 would be -1 times the quantity of 5 minus 2x. Number 6 would be -1 times 1 minus x squared. Number 7 is -1 times y minus 6. Number 8 is -1 times 7k squared minus 3. Now we're going to need this, because look what happens. When I go to factor number 1 out, I get x plus 3 times the quantity of x minus 3. Now notice, this binomial factor is exactly opposite of this binomial factor. X is positive and here x is negative. 3 is positive and 3 is negative. They're exactly opposite. If both terms are exactly opposite, then what I can do is just rewrite it as a factor of -1 and its opposite. So I take x plus 3 times the quantity of x minus 3, and instead I'm going to multiply that. I'm going to divide out a -1, and the opposite would be -1 times x minus 3. And now what I have is something I can factor out, the x minus 3's. So I'm left with x plus 3 over -1, or we could say -x, negative times x minus 3, or -x minus 3. You take the negative in the numerator or denominator. All right, now pause the recording and see if you can factor out a -1 and its opposite. Next problem. All right, now check your work. Numerator factors out to n plus 5, n minus 6. 6 plus n and 6 minus n. If I factor that one piece out by -1 times, I'm just factoring this one right here. Just factoring that second piece there. So I'm just factoring that. And what I end up with, I'm just placing my -1 over here. Okay. And now what I can do is cross these out. I don't need to rewrite that other 6 plus n. I'm left with n plus 5 over -1 times 6 plus n. Or I can do n minus 6. I can just leave it like this. As long as I'm simplified and I've divided them out, I suggest you stay at this point. Because at this point, you're not going to get yourself in trouble if you multiply it back in. All right, you can pause it and practice the next two. Now check your work. Okay, number 1. Number 3 was negative 2x minus 3 over 1 plus x. And number 4 is either x plus 10 over negative 5 or negative x minus 10 over 5. All right, the domain is the possible set of replacement values for a given variable. So, when it says simplify and state the domain for x, what that means, what are the possible values that x is allowed to be? Now, because these are fractions, there's a big rule in math, and that is that you can't divide by a 0. So that means you are never allowed to have a 0 in the denominator. So what I need to do is first factor out. Once I factor out, I can see what makes up my denominator. And it's at this point that I actually state my domain. I take both of the factors, set them equal to 0. Oops. Set them equal to 0. So I take x equals 0, and then I have x minus 4 equals 0. Okay, this is already here. I don't have to do anything to it. So x cannot equal 0, because if this x equaled 0, then my whole denominator would be a 0. So x is never allowed to equal 0. Now if I set this one equal to 0, I find that x also is not allowed to be equal to 4. Because if I put a 4 here, I end up with 4 minus 4 equals 0, and that would give me a 0 in the denominator. So what I say, we said that x cannot equal 4 and x cannot equal 0. Now I can simplify if there's any simplifying to do. Okay, now how I show the domain is I write that x is such that x is an element of the reals, and x cannot equal 0, and x cannot equal 4. So one more time. It is at the second point, it is right here where I'm fully factored that I figure out what my domain is. I set all factors of the denominator. Once they've been factored, I set them equal to 0, and I get that x cannot equal 0 and x cannot equal 4. But x can be any number in the real number system except for 0 and 4. Those are the only restrictions. All right, now pause the recording and try and state the domain for x in number 2 and simplify. All right, now check your work. I'm now in the factored form. This is where I figure out my domain. I get 2x equals 0 and x minus 3 equals 0. So now, to get x alone, I just divide by 2, and we find that x cannot equal 0. 0. Here I'm adding 3, and I find that x cannot equal 3. So the domain is x is such that x is an element of the reals, and x cannot equal 3 or 0. But now it's time to simplify. I can cross these out, and I'm left with x plus 3 over 2x. One more time. X is such that x is an element of the reals, but x is not allowed to equal 0 and not allowed to equal 3. If you did the third one, or if you need more time, pause it. Otherwise, check your work now. And that's the lesson for 10-1.